Testing. Okay, hello, we're back. I had to leave real quick, but I want to finish this day. So I've figured out how to make my feed larger as well, so that'll be helpful. Okay, let's get back to it. Okay, cool. So when we last left, we were wondering how to solve Q2, and I know this is definitely stupid, but I'm wondering, what if we just tried brute force? What if we try doing the dumbest possible thing? I'm curious how long it'll take. Because the updates themselves are really short. Like, if we take a look at the input, you know, these are like we said, these are, what, 22 characters? 23? Yeah, there's 23 things in them. So, I'm really curious, what if we just try every permutation and then see if it's correct? I am very curious about that. So let's try that, and we'll just see if it works. And if it works, great. And if it doesn't, we'll do something smarter. We'll try the topological sort and graph-based solutions. But so, if it's not correct, if the update isn't correct, we're gonna make it correct. So, okay, yeah, let me change this actually. We're gonna say if it's correct, then return none. And then down here, we'll start doing every possible combination. Stupidest possible way to do this. Warning. Okay. So we're going to get the itertools library. And I think there is itertools. I'm going to use itertools. Let me make sure I know how to use itertools correctly. I think there's a permutations method on it. Yeah, cool. So, use itertools, and then we're gonna go down here and we're gonna say for permutation in self.updates I dot permutations, all permutations of it. So we get to choose the length of them, which will be let's just make sure this works firstly. So for every permutation, we're going to try every possible ordering of the update. And if we find one that is valid, then we'll use that. So actually, yeah, let's do it this way. Permutations.filter for a given update ordering, or for a given like shuffle of the update. We're going to find one where the permutation is sorted, i.e. where the update is correct. So let's break this out. Instead of taking self.updates, we're going to say if, we'll take the update here basically. What's this? This is, we made some new type for this, didn't we? Yep. So this will just be the update. Okay, made some dumb mistake here. Let's just say is correct. What's going wrong here? Okay, right, this should not take the full vec, but you only need to take a reference to it. Can't infer type T, that's okay. We'll just say sum 0 here. And over here, we need to change this to soft updates as well. And this needs to be an actual I. Okay, cool. That's looking better. So let's get the stupidest possible way. This is the update. We're going to find every permutation of it. So for a given permutation, we're going to find one where the permutation is sorted. So self.update is correct for the permutation. And then with that permutation, we're then going to map it, take the permutation, and we're going to return the middle number. And if we didn't find one, we'll just unwrap, we'll panic. I expected enum option. I don't know what this is doing. What's going on here? Let's make this a bit wider. No, all of these should... Okay, yeah, this needs to be wrapped in a sum. Okay, what's going wrong here? Expected a right, those is this gonna make it correct now? Vec of U32, found vec of, well, over here. Okay, what is this permutation anyway? Okay, I'll clear this. That's weird. Update is correct. Okay, it's complaining that on line 39, he expected a reference to a vec of U32s. Well, okay, that isn't actually necessary. We can take a slice of it. Expected a slice of U32s, but found a slice of references to a U32. There we go. Again, this is a really dumb way to do it. but it seemed pretty fast. So, okay, let's see. Well, it's running in release mode to get actual speed. CR-R, that's cargo. C, R is release. R is run, and -R is release mode. So, I don't know, if this runs in like 20 seconds or so, yeah, it's a really dumb way to do it. But if it works, it works. I'm gonna put like a print to make sure we have some way to know if we're actually making progress. Okay, well, this, like I said, is actually going to work, but it's just going to be way too slow, so fair enough. Yeah, fair enough. Let me just see how many of these there are. This is 1178, 1370. So this is going to take too long for me to be bothered. Okay, cool. Well, you know, like we said, it was a stupid idea, but if it worked, then it would have been stupid, and it was really quick to do. So, all right, let's try and do this a smarter way. I guess I could parallelize this. Let me try one more extension to the stupid way. Let's add rayon, and we'll change this to be parallel iteration. And we'll do use rayon prelude. I mean, if you're doing brute force in parallel, it's a bit more reasonable, but you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in parallel. So, you know, this is, again, like a maybe okay approach. And I could log into my faster Linux machine, which has, I think, more cores. Or I could log into a prod server and use one of our big, nasty AWS bajillion core machines. But, you know, this is basically as far as I want to take this dumb brute force approach. I am going to tell my coworker who thought about doing a brute force search that this is not really feasible. Cool. Well, we tried that, and it was worth a try, but ultimately it does not actually work very well. So, okay, what can we do differently now? We can try... Oh, actually, I gotta do a work thing real quick. Okay. I think we should just do the topological approach. So let's... Okay, let's get rid of Iter Tools, get rid of Rayon. And let's try and be smarter about this. We're going to take a... okay, no, I think I'm out of time. I think I really got to get back to work. I got some work stuff to do. Well, it was worth a try. See you all later.